Hi students, this is a lecture on solving equations by factoring and the quadratic formula. Now here we're just going to be focusing on equations where the highest power is 2, so they're quadratic equations. And in this video we're also going to be focusing on equations that have only real roots, so we're not going to have any complex roots here. Okay, so none of our solutions are going to be involving the letter I, which is actually an imaginary number or a complex root. Okay, so real roots only in this video. Okay, so I'm going to give us a couple examples. For our first example, the instructions are just solve the equation. Okay, so you can really solve by any method you'd like. And if you're in my class, my algebra class, if you're using my math lab, it may say use the quadratic formula to solve the equation. However, you don't have to use the quadratic formula. Sometimes factoring is faster. But we're going to see how to do both approaches. That way we can use whichever one is quicker based on the problem. So for our first equation, for example number 1, we're looking at the equation x squared plus 8x plus 15 equals 0. Now with this equation, we already have all the terms on the left side. And the easiest way to solve this equation is to factor the left side and then use what's called the zero product rule. You could also use the quadratic formula, but here factoring is probably faster. So let me write out the steps as we go through these problems. So step 1 is move all terms to one side. Move all terms to one side, and either factor or use the quadratic formula. Okay? So move all terms to one side and either factor or use the quadratic formula. Okay, and here all the terms are already on the left side, so we don't have to worry about that. And so all we have to do is either factor or use the quadratic formula. So now with this one, like I was saying, to factor it, as long as your highest powers are written first, you can use the X method or the AC method. So we go ahead and factor the left side. So on the top we have 15, and then on the bottom we have 8. Okay, so we want two numbers that multiply to positive 15, but add to positive 8. Okay, so to multiply to 15, the first two numbers I think of are 3 and 5. So if we do positive 3 and positive 5, well, 3 times 5 is 15, and 3 plus 5 is 8. So that means that it actually factors as x plus 3 times x plus 5 equals 0. Okay, and with this one, because factoring is faster, I'm going to do this whole example by factoring. But if you can't factor it, then you use the quadratic formula. That's usually how people do it. Or some people just always use the quadratic formula, and that's fine as well. It's just the quadratic formula can be a little bit slower than factoring. But it's really up to you how you want to do it. But this one was easy to factor. So what we do next is we use what's called the zero product rule. Okay, so step 2 is use the zero product rule. All right, and this step, you only do this step if you factored. Okay, if you're using the quadratic formula, you wouldn't do this step. Okay. Okay, so I'll put if factoring. If you were factoring, then your second step is to use the zero product rule. So basically all that says is if you have two things multiplied together and they're equal to 0, then either the first thing is 0 or the second thing is 0. Okay, so it's just saying x plus 3 equals 0 or x plus 5 equals 0. Okay, so it's saying if two things are multiplied together, they're equal to 0. Well, either the first thing has to be 0 or the second thing has to be 0, because any number times 0 is 0. Okay, so notice all we really did here is we split it up into two equations, and we set each one equal to 0. Okay, and then we can solve each of these. For the first one, we can subtract 3 from both sides. So if we minus 3 from both sides, we get x equals negative 3. And for the second one, we minus 5 from both sides. So we get x equals negative 5. Okay, so we get x equals negative 3 or x equals negative 5. Okay, and that's actually the whole problem. So on MyMathLab, the way you write your answer is as a list. Okay, so they're going to write x equals negative 3 comma negative 5, and then we box that. And if you want to check these, you can. If you wanted to check them, you would have to plug in negative 3 into the original equation and make sure it equals 0. And then the same thing you'd have to check for negative 5. You plug in negative 5 into this original equation and make sure that it equals 0. I'm not going to do that though, because it's really not necessary. It's just something that you can do if you're not sure if your answer is right. You plug in the numbers that you got, make sure it's true. Okay? So the way we just did it was by factoring. So this first example was by factoring. That's what we just did here. Okay? But factoring only works on certain problems. Some problems cannot be factored. So for our next example, I wanted to show you one where you can't do it by factoring. Okay, so example number 2. For this one, we want to solve x squared minus 2x. Minus 3x. I was looking at the wrong problem. So x squared minus 3x minus 3 equals 0. Okay, x squared minus 3x minus 3 equals 0. Now what we need to do here is we need to, if you want to, you can try to factor it. But if we try to factor this, I'll put factor with a question mark. Well, we're going to need to have a negative 3 on the top and then a negative 3 on the bottom. And the problem is there's no two numbers that multiply to negative 3 and also add to negative 3. Because if we do negative 3 and positive 1, then they multiply to negative 3, but when you add them you get negative 2. Okay, and if we do positive 3 and negative 1, then they multiply to negative 3, but they add to positive 2. So either way it doesn't work. So factoring fails here. So this one is prime, cannot be factored. Okay, so this is prime, so that cannot be factored. So what do you do if you can't factor something? Well, that's where you are pretty much forced to use the quadratic formula. Now, some professors cover solving by completing the square, but I don't always cover that. I cover it sometimes when I teach it in person, but since this is an online class, I tend to not cover it because it just ends up being a little bit more confusing. But you might see it in some later classes like trigonometry or pre-calculus. Okay, but we're focusing on factoring or the quadratic formula. Okay, so if the equation cannot be factored, then we have to use the quadratic formula. I'm just going to write QF. Okay? So the quadratic formula is one of the most famous formulas out there. Oops. Let me zoom back in here. I pressed the wrong button, obviously. Okay. So we're going to use the quadratic formula, which is actually one of the most famous formulas out there. Okay, and the quadratic formula says x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Now, the quadratic formula can only be used on a quadratic equation. So that means this is the solution. This is the solution to the equation ax squared plus bx plus c equals 0. Okay, it's the solution to that. And the nice thing about the quadratic formula is it always works. It works on any kind of quadratic equation. As long as your highest power is 2 and you have a polynomial, the quadratic formula always works. So then some people don't even bother factoring. Some people just use the quadratic formula no matter what, and that actually does always work. Okay? So the quadratic formula always works for any quadratic equation. It's not like factoring, where some equations can't be factored. The quadratic formula works for any quadratic equation. And once again, quadratic just means the highest power is 2. Okay, so it's a very powerful tool, and the only problem with it is it's a little bit complicated. So it's negative b plus minus the square root of b squared minus 4ac all over 2a. And notice that a, b, and c are the coefficients of x squared, x, and then your constant. Okay? And I talk about this more in a later video. I talk about how to do it with complex roots, but here we're just going to see one with real roots, which means real solutions, not imaginary. Okay? So that's our quadratic formula. And the standard way to do it is to just write it down and then label A, B, and C, and then plug everything in and simplify. Okay, so what we got here is we have ax squared plus bx plus c equals 0. So we can see here that a is 1, b is negative 3, and c is also negative 3. So now we can actually just plug in a, b, and c into our formula. Okay, so x equals negative b plus minus the square root of b squared minus 4ac all over 2a. So we said that b was negative 3. Okay, so this one's going to look like negative of negative 3 plus minus the square root of b squared. Okay, and we're going to talk about plus minus a little bit more later. But it's going to be the square root of b squared, so that's going to be negative 3 quantity squared minus 4ac, so that's going to be minus 4 times 1 times negative 3, right? Because we said that a in this problem was 1, b was negative 3, and c was negative 3. So I'm just plugging those all into this formula here. And then in our denominator, we have 2a. So that's going to be all over 2 times 1. So there we were just plugging in a, b, and c all into our formula. And now we just simplify this. Okay? So we need to simplify this expression. Okay, so what we got here is negative of negative 3. Well, those minuses cancel out and give you a plus. Okay, so we got positive 3 plus minus the square root of, well, negative 3 quantity squared is going to be negative 3 times negative 3, which is positive 9. And then we have minus 4 times negative 3 is going to give us positive 12. So under the square root, we have 9 plus 12. And then in the denominator, 2 times 1 is just 2. Okay? And then how do we finish the problem? Well, 9 plus 12 inside of the square root is actually 21. Okay, so we have 3 plus minus the square root of 21 all over 2. Now, for the square root of 21, remember that 21 is 7 times 3, and 7 and 3 are both prime numbers, so we aren't going to be able to simplify that square root. So what we're going to do instead is we're going to split up our answer into 2 answers. Okay, so remember that this plus minus, I keep saying plus minus, but I haven't really described what it means yet. Plus minus just means you have 2 answers. One answer has a plus there, the other answer has a minus there. So plus minus is what I'm saying gives 2 answers. The only time it won't give you 2 answers is if the plus minus is in front of 0, then it'll only give you 1 answer. But normally it will give you 2 answers. So the answers are going to be identical. It's just right where the plus minus is. On one answer it's going to be a plus. On the other answer it's going to be a minus. So like here, our 2 answers are going to be 3 plus root 21 all over 2. Okay, so 3 plus root 21 all over 2. And the other one's going to be 3 minus root 21 all over 2. And then boom, that's the whole problem. Pretty cool, huh? So it's not so bad. And as you can see, we would never have been able to factor it. So we would never have gotten those square roots in our answer if we were factoring. So it's a good thing we did have the quadratic formula. Okay? And then you can watch my other video where I talk about how when you're taking the square root of a negative number, it actually gives you I. So in my next video, I talk about the quadratic formula with complex roots. So you're going to be able to see that there. So thanks for watching.